This is Calculus with Mr. Allenson, and we're going to be doing the 2004 test, problem 5 from the Form B, and this is the BC class. So what we're going to be doing is trying to find the average value of the function g, which is right here, and g of x equals 1 over root x, and over the closed interval 1 to 4. So from here to here, what's the average value of this function? So the average value of this function is going to be 1/3, because there are 3 units along the bottom, so 1 divided by 3, times the integral from 1 to 4 of 1 over root x dx. Now on the other ones we could just grab our calculator, but this is a non-calculator question, so we have to do this by hand. Taking the antiderivative, first put the 1/3, we're going to get 2 root x from 1 to 4. So plug in 4 and you should get 4/3. Plug in 1 and you should get 2/3. And so your answer is 2/3. For B, it says to find the volume of this region between 1 and 4 underneath this curve revolved around the x-axis. So the radiuses will be here, and you're going to get these circles as cross sections, and it's going to look something like that. So the cross sections are circles with radius equal to 1 over the square root of x. So each cross section's area is going to be equal to 1 over root x squared times pi, which is 1 over x times pi. The volume then is going to be pi times the integral from 1 to 4 of 1 over x dx. No calculator again, so you're going to have to take the antiderivative, which is ln x, remember the pi, from 1 to 4. If I plug in 4, I get pi ln 4. If I plug in 1, the natural log of 1 is 0, so I'd have minus 0. So that's just your solution on that problem. For C, C says, what is the average value of the areas of these cross sections of the same solid? Okay, so the same solid, what are the average values of the cross sections? Well, the function that gives me each cross section is right here. So if I want to find the average value of these circles from 1 to 4, I'm going to go 1/3 times the integral from 1 to 4 of, essentially that's pi over x dx. So taking the antiderivative, I'm going to get 1/3 pi natural log x. Evaluate from 1 to 4. Same thing's going to happen as up in here. When you take the natural log of 1, you're just going to get 0. So it's only 1/3 pi natural log 4. D, the last part, says that it talks about the average value of a function being unbounded from a to infinity as you go on forever, and it gives you a function for that showing what it's defined to be, and it says show that the improper integral, let's just write it down here, 4 to infinity of g of x dx is divergent. Show that this diverges. Okay, and you might remember that since the function's 1 over x to the 1/2, essentially that's less than 1, so those functions diverge. But to show that, what we're going to do is we're going to go, it's equal to the limit as b goes to infinity of the integral from 4 to b of 1 over root x dx. That's going to be equal to the limit as b goes to infinity of 2 root b minus 4, which is equal to infinity. As b goes to infinity, the square root of b goes to infinity. So this shows that this diverges. It also says to show that the average value is actually a finite value. So average value would be to take this thing and go, well, I'm going to go 1 over b minus 4 times the integral of 4 to some value b of g of x dx. That's equal to, in this case, the antiderivative is going to be the same thing, so I'm really going to get 2 root b minus 4 over b minus 4. And the limit, as b goes to infinity, of this is equal to 0 because the denominator grows faster than the numerator. This gets larger faster, making this go to 0. The points on this problem, on A, there are 2 points, one for the integral and one for taking the antiderivative and evaluating it to 2/3. For B, you're going to get 1 point for the integral and 1 point for taking the antiderivative and evaluating. For C, 1 point for the solution. And for D, there are 4 points. 1 point for writing down this right here is equal to 2 root b minus 4, and one that's showing that that actually goes to infinity when you take the limit as b goes to infinity and that it diverges. Another point for writing this integral here equal to 2 root b minus 4 over b minus 4, and another point for showing that as b goes to infinity that goes to 0.